I'm very happy to be here with you to be able to introduce a new member of our automated tissue dissociation system from Singular. And for those who are hearing from us from the first time, Singular Biotechnologies is a global company, and we are focused in offering end-to-end solutions for single-cell RNA sequencing. But of course, you will see now that we are much more than that. So we do many other things and offer many other smart solutions for your research. So for this end-to-end solution for single-cell sequencing, we have kits and products for helping you with your tissue dissociation, which is where we are going to be focusing today. And then going through the core of our technology, which is our sCope chip, which is a microwell-based technology for single-cell partitioning, up to sequencing. And of course, we can provide you with published-ready data with our very experienced bioinformatician team. So in Singular, we are over 500 employees distributed all over the world. We have offices in Cologne, from where we are speaking to today, 2 offices in China, in Singapore, and also in the US. And we are very proud to have served and to have helped more than 4,000 labs around the world, more than 20 countries. And pertinent to today's webinar, we have already processed more than 1,000 different tissue types, which led to more than 300 publications. So we can say that we are sort of experts in tissue dissociation, and we are very happy in doing so because we do believe that tissue dissociation is the critical first step for many of you in your for your different biological applications. So, for example, as you know, and you mentioned that many of you are working in the area of cancer research, immunotherapy, stem cells. All these different research focus are actually in need of very good tissue dissociation. For example, for cancer immunotherapy, we have that you may want to study the tumor microenvironment or immune evasion. Perhaps you want to study, for example, model organs development. Yes, if you are basing your research on organ research, for which you also need an excellent single-cell suspension as a starter. Or perhaps you're investigating some neurological functions, development, disease. You want to characterize your immune responses, develop vaccines, etc. You know better than I that for all these, you need to start with a good cell suspension or a good, we will see later, nuclei suspension or others. So for us, as also you are working with this, you may know, and as you share with us, that you normally face problems mostly with incomplete dissociation from the tissue, but also with low cell viability. And these are some of the typical difficulties that all researchers face when dissociating a tissue. So other than, as you mentioned, the incomplete dissociation, the low cell viability, we also know that low sample input is a big issue, mostly when we are working, for example, with clinical biopsies. But we have some also difficulties that are intrinsic for the tissue type, as we can mention tissues with, for example, highly connective tissues, or as it can be for skin, or that have high enzymatic activity, intrinsic high enzymatic activity, as it will be the pancreas. But again, we have even more factor to add to these difficulties, as it will be the batch viability. So the necessity to combine different enzymes to prepare the cocktails that different persons working on this research in this moment, which can produce variable results. So of course, as offering, when we want to offer solutions for the dissociation, we can also consider manual, but a manual dissociation actually brings along most of these specific difficulties. So to reduce all these drawbacks from tissue dissociation, we are specializing on automated solutions. So with these automated solutions, you will be able to reduce the manual labor, the operation time, and what I found in most of our customers, what they are looking for the most is a high reproducibility. This is not new to us, and in Syncreon we have been working for a long time already in improving our solutions to offer you the smart solution for your tissue dissociation. And for this, we have many products. So from the very beginning, from the tissue preservation, we offer a unique tissue preservation buffer that will allow you to preserve your sample for up to 72 hours, your fresh tissue. And we offer dissociation solution, and we also have a universal buffer for your dissociation, a ready-to-use universal buffer, reducing also the handling. Yeah. And we had 4 already launched, and you might know them. We have our PythoN and PythoN Junior. But now, today, we are here together to introduce the newest member, as I say, of this family, which is PythoNi. So PythoNi is also a system that is going to combine both enzymatic digestion of the tissue with mechanical dissociation to have the best and the more precise dissociation of your tissue. As the features of this PythoNi, so we know it has a high definition folder screen, which is another thing in comparison with the other 2 instruments from this family, and is a very intuitive touch screen. So you will see now how easy it is to use and to set all your programs. In addition to this, we have 8 different channels that can operate either in parallel or independently. And they have a very nice feature, a very nice design, where you can actually see in real time, observe the tissue dissociation. We also have many customizable parameters. We offer you in these interfaces. You will have a 100 reference program from which you can build up from your own programs. Yeah, but you also can configure more than 500 new programs that allows also to have more than 126 steps. So, and we can also, for configuring this program, we can change the speed, the cycle time, the direction of the rotation, and very importantly, and this is the newest feature, you can also select in which temperature you are going to be working. So you can work at 37 degrees, as you might want to do for most single cell isolation, but you can also switch off the heating and you can work at room temperature. So if you are deciding to work at 37 degrees, you will see the PythoN can reach this temperature in no time, in less than 2 minutes, and the temperature is preserved and is consistent throughout the whole experiment. And the closed design of our units will free you from all the external environmental interferences. In addition, and this is also something that I think is a great advantage of our PythoNi, is that you can process different tissue amounts, going from very small tissue amounts of 10 milligrams up to 4 grams. Which is, I think, quite amazing. Of course, you need to adapt this to the amount of solution that you will ask for this dissociation, but it's very possible, and it offers a lot of flexibility for your research. And the workflow for working with Syncreon PythoNi is quite simple. As I mentioned, let's say you have some fresh tissue, so you will have it in your preservation buffer up to 72 hours, as I say. Then you will wash the tissue, add it to the units, to the dissociation unit that we will see in a moment. You will add your tissue dissociation buffer, put it in the tray goes inside the instrument, you set up the program, and once that the run is finished, you will hear beep, the instrument will let you know, and the solution is, the suspension is ready for any posterior processing if needed, and ready for your downstream applications. But what I want to convey mostly in this webinar, in this presentation, is that our PythoNi is one tissue processor with infinite possibilities, because it does not only offer you the possibility to have single cell suspensions, but it also works as a tissue homogenizator, and also it will provide you some single nuclei suspension. So it has many, many more applications. And I will show you here some results about some of these applications, but of course, as I say, the possibilities are infinite. So In the beginning, as I introduced the company, so we're mainly focused on single-cell RNA sequencing. So for us, having a high-quality single-cell suspension is essential. And as you can see here, in this graph, we show the dissociation of the single-cell suspension, the yields of the cells normalized by milligram of tissue. All of these are mouse tissue. We have heart, testicle, liver, most of the tissue types, most common tissue types. And you can observe that for all of them, we have a viability over 80%, which is ideal, is very good, and it is perfect if you want to continue, for example, with a single-cell RNA sequence assay. In this example, we can see a mouse liver, and as you can observe, we have a very good representation of most of the cell types that we would expect to find in this tissue. But it doesn't stop there, so this single-cell suspension can also be used for other applications. Another example is a flow cytometry. And these results I'm going to show here was actually explained much in depth in another webinar from Singular that is available in YouTube by Dr. Ma Baide, and you can look later for this talk. It was very interesting. But here shortly to show you, so in this sample was collaboration between Singular and Cytec, in which they processed the 15 patient-derived lung cancer in our PythoNi. After reaching the single-cell suspension, they continue with the cell staining using a 21 antibody panel. And then they acquire the flow data, and after the data analysis, some of the observations they could reach, all of these were non-small lung cancers. So what we can observe in the first graph here is the composition of the suspension differentiated between tissue cells and white blood cells. And we can easily see that for samples here 11 and 13, we can assume that this is coming from cold tumor, as we see a very low infiltration from T cells. In comparison with the others that could be hot tumors, where we have a higher infiltration of T cells, and we also will be expecting to have a better response to immunotherapy. In addition, we can also have a very good distinction and representation of all the different white blood cells present in these patients. And we can conclude that evidently, like the predominant immune cell in these lung cancers are the T cells. Again, this single-cell suspension can also be further used for cell culture. And in this example here, we process a mouse kidney with the program that is mentioned below, which it takes around 15 minutes. And after the dissociation, the cells were plated and seeded, and you can see that you have a high viability after 2 days of the seeding, around 90%, which is sustaining in time after 5 days. Okay, this plate already is asking for some splitting, but you can see you have a nice growth and a very good viability. But as I say, we are not, PythoNi doesn't only offer you the possibility to reach a single cell suspension with a high quality, but can also be used as a tissue for tissue homogenization. In this case, the results we are showing is a tissue homogenization that we use for DNA-RNA extraction. So the graph in the left shows the DNA extraction per milligram of tissue. These are also mouse tissue, and you can see that we reach a very good yield both for the DNA and for the RNA. And of course, this could be potentially used also for proteomics downstream. Now, if we want to use this RNA, for example, for bulk RNA sequencing, which we also offer in your company, it's important to check how the integrity of the RNA. And we did this both by calculating the 28S, 18S ratio here. That is very high, so ideally it's close to 2, in between 1 and 2, as it was for most of these samples. And we also back up these results, showing that this isolated RNA actually preserves their integrity. As you can see in this other graph with the RNA quality number, which is compared with the ring value, which is all above 8. And as a last application, we can also use our PythoNi for a reliable single nuclei isolation. So in these two examples, I'm showing you some mouse intestine on the left, mouse brain on the right. So both of these are automated dissociations, and we are here comparing the reproducibility of the nuclei extraction. And you can see that for both tissues, it's a very high reproducibility, and we have a very good representation of all the cell types that are present in these tissues, the most important cell types from these tissues. And we do recommend always, especially for brain tissue, to proceed with single nuclei isolation, as the isolation, as you know, of intact neurons is quite difficult in a single cell environment. So we always recommend for going for a single nuclei. And you can see here you have a high percentage of inhibitory neurons, excitatory neurons, and so on. So I hope that in this short presentation, I was able to show you how PythoNi is more than just a tissue dissociator for achieving single cell suspension, but can be also used as a tissue homogenizer and also as, to generate single nuclei suspensions. So of course, I can show you here, I have only shown you results for some of these applications, but for example, the single nucleus suspension can also be further downstream used for proteomics, microscopy, for doing any CRISPR-based screening as per seq. And the homogenate will not only be used for RNA extraction and DNA extraction, but also for proteomics, metabolomics, any tissue-specific assay, as well as the single-cell suspension, further than using it for single nuclei, RNA sequencing, or single nuclei attack-seq. Can be also used for methylation analysis, for example, or nuclear protein profiling. So that's it for the first part of this webinar. And I'm, thanking you all for joining and for staying with us into here. And I'm looking forward to your questions.
Yeah, we already have some questions in the chat that came during your presentation. So I'm going to start with the first one. How do you measure viability?
That's a very good question. So how do we measure viability for example, a single suspension? We normally use Luna. Yeah, so that's our most reliable viability measurement. And of course, we also do some triple staining, but the higher would use this double staining with IOPI. This is the most trustable method that we know for measuring viability.
And another question, again from Peter, that arrived a while ago. Do you calculate RIN values of the RNA?
Yes, we also measure the RIN values of the RNA. And we do this normally, not for every single cell RNA-seq, but we do it often for the bulk, which is far more important. You need to also normalize your samples. But of course, yes, we do this measure routinely in our labs.
Okay, we have another question. Does the instrument also cool down?
That's a very good question, mostly because we have also shown applications for which normally we will need a cooling system, or people would prefer to do it at 4 degrees, but the answer is no, not yet. It might come an update, or we are working on an update. But we have seen, for example, for the applications I showed, this very nice single nuclei data, we performing in our PythoNi at room temperature.
Yes, and can the dissociation units be reused?
That's another very good question that we get very often from our customers, and they cannot be reused. They are only used and they are less disposable.
Okay. Would it be possible to work with my own enzyme cocktail?
Would it be possible? So, of course, all the results that we have shown have been done with our own enzyme cocktail, so with our universal dissociation buffer. But of course, you are free to test it with your own enzymes. And we do also offer other specific buffers. So we have optimized the buffer for dissociation of skin, and also to use with downstream application as flow cytometry, which is our flow buffer.
Yeah. So I guess now is the time to move to the live demo. And of course, while we set up and while Estefania is doing the demo, you can, of course, write any question that pops up in your mind here in the chat. Now we're going to move on to the other camera when you...
So, in the main interface of the instrument, you will have all the subunits, yeah, with all the details of which program is selected, the temperature of the different units. You will also have the percentage of the run, and you can add many other details to this interface by choice. So I will show you how to do that later. But first, let's think that we want to establish a program. So if you want a program, what you can do is go to the programmer interface. In the programmer interface, you already have 10 previously selected, so preset programs that from which you can select. They are not modifiable, but don't worry because you can always add new programs. So the new program can be added easily. If you already have a free slot, you can just modify all the details by just pressing the edit button. Yeah, and you can change all the different parameters. Okay, once that you are finished with the editing the program, you can edit also the name. And once that this is finished, you will just save all the changes. But let's say that you are editing a program and actually don't want it, you can just press leave. And the instrument will ask you, are you sure to modify or not? And you can select, yes, I want to leave, or I want to stay. If you want, you can also add, and as I say, PythoNi have over 500 different programs that can be added, like by pressing the add new program, you can add a new program that is also editable. Yeah. Another thing that you can do in this interface is to also like a program. You will see it is very easy to see. We will upload a recorded video of this, so you have a better visualization of the screen. And another feature that you have is that you can like a program, and then this program will be stored in your favorite folder. So we have also a favorite folder for easy and faster access to your programs. In addition to this, as I mentioned during the talk, you also have up to 100 different programs already set up as a reference for you to use for many different types of tissues. Now, this is all with our programmer interface, and then we can also go to the next interface, which is the settings interface, in which you can select the language. You can select if you want to run independently the different units, or you want to use it under subordination. And you have different settings that you can change. You can remove the sound of the buttons. You can remove the sound when finishing a program. You can allow to see the temperature displays, the countdown displays. You have the date, the time, and that's most of the most important settings in this interface. And in the latest one and the last one, the information interface, you will have the version of the machine that you are using. And other than the version, you will also have the information on the company. So once that you have to set up a program, what you will do, and this is very simple. So you can just press in the title. So on top of the units that I see, you can see here. So here you have the image of the unit. So you just press on top of the unit. And once you press, you are inside the programmer interface. You select your program of choice and just select OK. And now, on top of the unit that you have selected the program for, you will see displayed the name of the program. In addition, you will have the measurements constantly of the temperature in that unit. Let's say you want to actually start pre-warming the unit before starting your run. You can just press the unit and you will see it that it changed to yellow. I hope you can see it. I doubt it, but I hope so, that you can see that these units now are in color yellow, and it will be like this, and it will increase the temperature up to 37. And then the color you will see, it will change to red. Now, for once that you have selected your program, your unit is warming up, you can also open the unit. And once that you open, here is what you, so this is a dissociation unit. As you can see, the dissociation units have grinding palms, yeah, and have also the structural details that will help to position it in the perfect place inside the instrument. So once that you position this inside the instrument, you will see when it's well located, because you cannot rotate it anymore. So if you can still rotate the unit, it's because it's not well placed. So you have to put it in the correct position. And after that, you can just close the instrument. And you can start your run, yeah? And as I say, you can visualize the run while happening, yeah? As we are working independently now, that's selecting settings that we have, so we can still keep on working with the other units. Yeah, we can select the different programs for each of them. Now, as you might be able to see, hope that difference between the yellow units, this is still warming, now it's done. So the difference between the preheating settings, which is the units colored yellow, and the already heated, this already at 37 with the unit that is now in red. Yeah. So this is when we want to work at 37. But let's say that we don't. Let's say we want to do some nuclei isolation, or we want to do some RNA extraction. Then we go to the programmer interface. And we want to set up our program specific for our tissue. We want to load our program. And when we are loading our program, it will ask us if we want to use the auto heating or we want to switch it off. So you can just simply, by pressing this button, switch off the auto heating. Yeah, we selected, we say okay, and our program won't have any heating, so it will run at room temperature. Of course, we have also the possibility to stop the run at any time. So for this, we just press the pause button, and it will actually ask you this dialog box. It asks you if you want to stop the run, to pause it, or to cancel. If you select to pause, then the dissociation will stop, and you can restart it at any moment. Instead, if you select stop run, the run will automatically stop, and the unit will open for you to retrieve the sample. Yes, if you want to restart this program after stopping it, you have to set up again the program, yes? So this will finalize, the stop finalize your run. Yeah. So those are most of the features. As you can see here, you will be able to follow the progression of your dissociation. And when the dissociation finish, you will hear a beep if you choose in the settings, and it will be ready, and you will be able to open and retrieve your unit for continuing with the downstream processing or your sample. So now, for closing the machine, let's stop all programs. We can retrieve the flexible screen, yes. and we will switch off the machine easily as always, just pressing the switch off button in the back.
Again, thanks for joining.